Okay, we're talking about watershed modeling with DEMs. And basically what we're going to learn to do is do a delineation of watershed using DEMs, and then use WMS to get the parameters like Chris was talking about earlier. So now we're in the basin delineation stage of our modeling workflow. And so Chris ran a program called Topaz.
Or Topaz.
Topaz. He ran Topaz. I got stuck on that. And so what Topaz did was, it did what we're fixing to show here, which is this is like a DEM. So these are, imagine those are elevations and say meters. And we have a 1 meter, resolution. So that's what a DEM looks like. It's just values of elevation on some standardized grid. And so, so what Topaz do first would be to look at all the cells and compute the flow directions in all the cells. I think this thing. So we pick like this cell, we can look at all the cells around it, compute the flow directions, and then we should have that. So we have the flow direction. This is like using an 8-point scheme. So we look at the flow directions in the 8-point scheme. And so that's where each cell, how it flows, basically, from a higher elevation to a lower elevation. Flows based on elevation, because that's all you've got, right, is elevation. And so that maps out the flow directions for every single cell in your DEM. And so then you have that flow direction mapped like that. And then if you start to look at flow accumulation, that's like the second thing that it does. So if you look at like a cell, so all the little arrows drain into that cell. And so we look at that cell, and that has a 5-cell drainage area to it, if you will. And so then you can go through for each cell and look at, you go through, and then that one has 6, and then that one has 12, and that one has 21, and then the entire DEM trains to that point and has a 30-cell flow area into it, or a watershed above it. And so you can back up in time. You imagine, so if you put your point up there, like your little outlet point, then you would have a 5-cell, so that, if you pick that one, then you would have that area above it, and so on and so forth. So you can imagine, put my little outlet there, and then I get these different basins. And so then you could go through, and for every cell, you can compute its basin above. Some of them have nothing flowing into them, so they're 0. And some have multiple ones, up to the biggest one has 30 cells flowing into it. And then if you were to pick some threshold for what a stream is, and I'm guessing you've picked this threshold of 10, then that would be your stream network. So any cell that has more than 10 or more cells draining into it is considered a stream. And that was part of the thing that Chris didn't mention it, but that was done in the WMS as well. We picked the threshold for our streams. That's the only way you can get a stream, is to pick some threshold for it. And if you change it to 5, then your stream network would get bigger. So as you lower your threshold, the more dense your stream network is going to become. So then that's our stream network. So we put our watershed there, which I was imagining doing before, and then that would be our basin up above it. And if we were to put it in a different place, and if we were to pick a sub-basin outlet, say we're doing a sub-basin type model, and then there would be our full basin, and then our sub-basin, and then some of the cells flow outside of our drainage area, and they would be excluded from our domain. So that's the concept behind how that is literally how the computations are going on inside of the WMS too. Delineate the basin, pick where the streams are, throw out the cells that aren't in the basin that are in the DEM. So 7 steps in WMS to do the DEM delineation. So we're going to read those elevations in, compute the flow directions and the accumulations using topaz, define the basin outlet, convert the DEM streams to feature objects, define our basin, convert that basin to a polygon, and then compute the basin parameters. And then the next step for us would be to create a grid irrigation model. So we're going to read in our elevations. I'm not the best person in WMS. Chris, you ought to come do this part.
What's that?
You ought to come do this part.
You want me to?
Yeah, because it's it's very WMS-y, yeah.
That's still.
Why don't you come do this?
Okay, you want me to?
Yeah. Switch up.
I'm used to it.
You're much better at WMS.
Right. So, this is just going through the 7 steps. The following slides are just going through the 7 steps of DEM delineation. And so first you're going to read your elevations. So those are the elevations. To read, we've already talked about how you can get them. You can either, maybe you just download them from somewhere, or you get them from inside of WMS like we did this morning, or this earlier. Then you, I guess the other thing is you have to make sure, when you read your elevations in, it's going to show up under GIS data here. But you need to get your elevations as a DEM under terrain data. And so you just need to right click on it, select convert to DEM. That'll create, and that'll bring up this window. You usually just hit OK here because it's going to make a DEM that's exactly the same by default, unless you want to resample it. And actually, when it comes down to it, this DEM here and this raster, so this is, I would say, call this a raster under the GIS data. This is a GIS data raster. And then this is a DEM WMS. I would say those two things are basically the same. The only difference is you can't really use this for your creating your Gaussian model. This one, WMS can interpolate the elevations from this DEM onto your 2D grid. And so you have to have it as a DEM. The second thing, after you have your DEM, you run Topaz or TauDem. TauDem is a program that's a lot like Topaz, where it computes flow directions and flow accumulations from an elevation grid. And so it's the same type of program. It's just a different code base.
Is it considered better now? Is there a reason not to? Topaz has been around a long time. Is there any reason not to continue to use Topaz and you need to switch to TauDem?
No, usually I tell people if the only time you would use TauDem is if Topaz is taking a long time. So Topaz, one thing you'll find with Topaz is it's really slow, and it just could, if you have a large EM with 10,000 by 10,000 cells, and it's going to take 3 days or maybe even a week to run Topaz. The one when we ran this morning, it took like 2 seconds. That's because our DEM was a lot lower resolution. It didn't have very many cells. But so if you're taking a long time, if you have a really big area, or you have a really high resolution DEM, you might have to run TauDem instead of Topaz. Topaz, in my experience, topaz is always going to give you better answers for your streams and your watershed boundaries. I don't know why. It's just, that's just how it is. So I always use topaz if I can. Anyway, you compute your flow directions and flow accumulations using topaz or tau DEM. And this is just the window. So when you do that, you can, if you're in the wizard, you just step through the wizard and do it. But if you're not in the wizard, you select the menu, and this is the window that comes up when you run topaz. And it runs it. Oh, and also you define the units. Make sure your projection is set correctly, and make sure your areas, what the when you WMS computes the areas and stuff of your watershed, make sure those are the units that you want to compute things in. And in Geisha, actually, these areas and distances don't matter because Geisha doesn't use that stuff. It just uses your model units. So make sure, the main thing is make sure your model units in Geisha are set to meters for horizontal and vertical. You run topaz. When it runs, it brings in the output. And the output, you usually don't see all the output, but the output is flow directions and accumulations. What does that mean? That means for each cell on your DEM, you have a direction of flow that could be one of 8 directions, because each cell can go to one of its 8 surrounding cells. And also you have a flow accumulation value, and that's the number of cells going to the number of cells flowing to each cell on your DEM. So each cell has a value that is the number of cells flowing to that cell, as well as the direction of flow from that cell. That's your flow direction and flow accumulation grids. And those just become part of the DEM. So you don't really see those grids as separate items in the Project Explorer, but they become part of the DEM when WMS reads those in. There are different display options, so you can display the flow accumulations here. Some value has been set that's a threshold value, and above, if my flow accumulation is above the threshold value I set, and that value is usually specified in some areas as some area value. So in this case, usually it's like square miles. If my flow accumulation is greater than 1 square mile, then WMS will display those cells as a blue square. Any cell that has a value above that flow accumulation has a blue square, and that's all these blue lines. These blue lines are just flow accumulation values above the threshold that you've specified.
The threshold that you specify in WMS is an area. So all it is it takes that DEM cell area multiplied by the number of DEM cells.
That's right. It's an area rather than a number of cells. You don't specify the number of cells, you specify an area. So, and then the thing about the threshold, so you can change, the threshold is just a display option. So in this window, this value right here is my threshold. So this is the display options. If I change this to like 2 square miles, am I going to have more streams or fewer streams than 1 square mile? So if I change it to 2 square miles for my threshold, what do you think?
What do you guys think of that there?
Can you repeat the question?
So if I have a default, the default accumulation is 1 square mile. If I change it to 2 square miles, am I going to have more blue lines or fewer blue lines? Did somebody say fewer?
Yeah.
Yeah, so fewer is the answer. So you have fewer, the higher the threshold, the fewer blue lines you have, and that means the fewer streams you're going to have in your model. Same thing, if it's lower, then you have more streams. And so that's, I mean, in some ways that value is not just a display option, but it's also important for determining where your streams are and especially for geisha models. You don't want too many streams, but also you don't want too few streams. So here we've increased the decreased the threshold, and so we have more streams, more blue lines. As you increase the threshold, the 2, you have fewer. Increase it more, you have even fewer blue lines. Once you've defined your threshold, you define your outlets. Yeah.
So next question is, what's the right answer?
Where's threshold?
What's the right answer for your threshold?
Streams should not be static. It should be dynamic.
Just my first second.
No.
So the way you figure out what the right answer is, usually you'll form like a topo map as you back on an image, and then you can sort of see where your blue lines are compared to what blue lines are topo map. Okay, so you'll see some are shorter, some are longer. Pick up in the middle, kind of makes it roughly the right sense. Right. And then your mapping, come close.
Well, the actual answer for modeling is you stop adding orders of streams that stop making a difference in the answer you care about. That's the answer for everything. Stop adding stuff that stops affecting what you're trying to get the answer for. And the same goes with streams. And back in the day, none of this stuff was automated. We used to hand digitize those streams, and I told everybody to put in a core stream and you add streams as you keep adding streams until you don't see a difference, and then you're done. And then you don't add any more because there's no point, because it doesn't affect your model. Now that we do it this way, it's a little less, you got to kind of make something up. But you can always go back and add streams. I think it's better to start with too few streams than too many. Because you can always add more streams, and we do sometimes. So start with less, and then add, you can always hand digitize the streams in later.
So I don't know if the people on the computer heard that, but Chuck says that what would you say, Chuck? What do you want me to tell him?
Stop putting in streams that stop affecting the model. That's the answer.
Okay, so don't put in too many streams to begin with. And then if you want to, at some point, you can add more streams. So you don't, anyway. Okay.
Close enough.
After you have your flow accumulation determined and you have your threshold defined, you can define outlets. One thing about outlets is you want to define an outlet on an area of high accumulation. If you define it outside of an area of high accumulation, you won't get a very big watershed, or if you even get a watershed. So you just want to make sure you define your outlets on the blue lines. If you click close enough to the blue lines, WMS will just snap to those blue lines. If you click too far away, though, it won't snap, and so you'll get a bogus watershed. Once you have created your outlets, so this is in our wizard. When we went through the wizard this morning, it did a lot of this stuff automatically. We didn't even go through these individual steps, but after you create your outlets, what you want to do is you're going to convert your streams to feature objects. And what that means is wherever I have these blue lines on my DEM, it converts those blue lines to what we call GIS vector data. And by vector data, I mean it's kind of like a shape file, a shape file with lines in it. And so you actually have point to point, like you're doing a dot to dot between each of these flow accumulation values. And that's what WMS just does automatically for you. But that's converting the DEM streams to feature objects. And by feature objects, so there's some terminology. In WMS, any points, lines, and polygons that are in the map module, and by lines I mean not only just lines, but also polylines. Points, lines, and polygons that are in the map module of WMS, we call those feature objects. And so when you're converting DEM streams to feature objects, converting these blue cells on the DEM to polylines that represent streams in the map module of WMS. That's what it means to convert the DEM stream to feature object. There's a menu command that does that, so you don't have to worry about how it's done. This is the menu command, DEM to stream arcs. And then you make sure you specify the right threshold. You could change it here if you want, but usually you just want to go with whatever you have. And that creates a stream lines. Okay. Quiz question. Which two delineation functions are performed by Topaz? A, flow direction and computation, flow direction computation and basin delineation. B, basin delineation and computing geometric parameters. C, flow direction computation and computing geometric parameters. Or D, flow direction and flow accumulation computation. Anybody want to be brave? Somebody say D? D? It's D.
It's always
Flow direction and flow accumulation. D is in dog. Flow direction and flow accumulation computation. That's what Topaz gives you. Flow direction and flow accumulation. Actually, these other things, so like geometric parameters, WMS computes the geometric parameters internal to WMS. Topaz, remember, Topaz and TAUDEM, these programs that compute flow direction and accumulation, those are all external programs. We don't really control the code behind those programs, so we run those externally from WMS and then just bring the results in. But the correct answer here is D. Okay, one more quiz question. If we have a larger value, and we've already done this, so I don't know that we need to. A larger value for flow accumulation threshold, we would expect the streams created from the DM accumulation cells to be relatively shorter. I think that's the answer, right? The streams created would be longer if you have a larger value for threshold. The streams created are not affected. It's A. So A. So we've already kind of discussed that. Okay, after you have created your streams, define basins. And WMS, if you have one outlet point, it's going to create one basin unless your outlet point is at a stream junction. Then WMS will create a basin for each upstream stream from the outlet point. So for a Geisha model, you only want one basin. And so I would say, we're going to show what the watersheds look like here. So these are I have three sub-basins in this watershed model. The downstream outlet point, then I have an upstream outlet point that's at the junction of two streams. And because it was at the junction of two streams, WMS created two upstream basins. For Geisha, you just want one outlet and make sure it's not at the junction of two streams. You either make it a little bit downstream. If it is at the junction, make it a little bit, just a tiny bit downstream, and you'll get that whole basin that you need. Or you can do it upstream from a junction. That's the next step. Convert boundaries to polygons. And all this does, so this, when you define your basins, the basin IDs are stored on this DEM. So remember, the DEM is up here. that DM has a lot of information. It has the elevations, the flow directions, the flow accumulations. It also has the basin ID for each cell on that DEM. And so right now I have the basin IDs assigned to my DEM, but I need to define a polygon that represents the basin boundary for that DEM. And that's the next step. And the reason I need a polygon is because I have to use that polygon to create for Geisha, you use that polygon to create a grid. If you're running a lumped parameter model, you take that polygon and that's your watershed boundary. Each of those polygons on the basin boundary are your watershed boundaries. But for Geisha, we need that polygon to create a grid. So that's the convert boundaries to polygons. And once again, these polygons are stored in the map module. In the map module, you'll see under coverages here, map data coverages has this drainage coverage. The drainage coverage is where the streams, the outlet points, and the basin boundaries are all stored as polygon points. The outlet points are points, the streams are arcs or polylines, and the basin boundaries are stored as polygons. So to convert the boundaries to polygons, that's what you end up with. So these black lines represent the basin boundaries. The blue lines represent the stream lines. And then I have an outlet point here and an outlet point here. Usually those outlet points, the default display option is that there's a yellow circle around the outlet points. You can't really see it very well here, but it's a hollow yellow circle with the outlets. Then you compute your basin parameters or compute your basin data. To do that, there's just a menu command here in the DEM menu, select compute basin data. And this window is going to come up again because when you compute it, you define your projection, your horizontal and vertical units, your projection, and what you want to compute your basin data in. And you actually don't, I think for Geisha, you don't even need to compute your basin data because it doesn't use these areas that are computed from your basin data. But what that does is it computes your areas and slopes in each of your sub-basins of your watershed. If you make a change, if you add an outlet or delete an outlet or something in your watershed, then you'll need to redefine your basins. And so these are all the parameters that WMS, these are the geometric parameters that WMS computes, and you can look through those. There's actually some hydrologic parameters that are listed there too, but most of them are geometric parameters. Now the wizard we went through already. This wizard is really handy because what it does is, these are the 7 steps. And in the wizard, it takes you through each of these 7 steps. So these are the 7 steps for DEM delineation that we just went through. The wizard steps you through these 7 steps. So the watershed data step is reading the elevations. This compute flow directions and accumulation step is step number 2. Then you define your basin outlet with this choose outlet location. Now there's some steps in between in the wizard because there are different ways of getting data. And so sometimes you might want to use one of these other ways, but most of the time people are going to download data using web services and stuff. And the delineate watershed step does steps 4 through 7. So anytime you click on that delineate watershed button, it's going to do all these steps together. Now one thing to keep in mind is if you do click on that button, any manual changes you've made to your streams, which you can actually change manually your stream locations, but any manual changes you've made to your streams in WMS will get erased. They're just going to go away. And so be sure don't click on that button unless if you have made manual changes, you don't want to click on that button because it's just going to delete them. Or you can save your model and then click on it. I don't care, you can do what you want, but there's no undo command in WMS. So the delineation, okay. The other thing that we have mentioned is sometimes it's a good idea. So one thing, because Topaz, when you run Topaz, it's just an 8-point flow direction. So the flow can go in only one of 8 directions. Because of this, the streams can kind of look blocky sometimes, or they're not really actually where the water goes. So sometimes you might want to smooth your streams and smooth your watershed boundary. So like what I mean by that, if I zoom into the watershed boundary in my streams here, this is what it looks like if I were to zoom in. And so you can see that this brown line is the watershed boundary, this blue line, these blue lines are the streams. It's kind of blocky. And when there's an option to redistribute the vertices on an arc in WMS. And when you select that option, you can select whatever you want to redistribute. You can select the redistribute option, right click and select redistribute. And then you specify what spacing you want to redistribute to. So I want to change this to 500. So that means I have 500 meters or feet or whatever the units are between each point on my boundary and between each point on my streams. And you can do these separately if you want. If I do that, and usually I turn on this option to use a cubic spline, that'll smooth it out, smooth the boundary out and smooth the streams out, just make it look more natural. And so this is what you end up with. Something that looks a little bit more natural. And I don't know if this really affects the results that much, but it does look nicer on paper. It could also affect the results, so you just got to keep things in mind. That's smoothing. Other thing is sometimes you're going to have an area where you have a roadway embankment or a railroad embankment or a canal. And so like, for example, here, we're going to zoom in here. I think where we're going with this is there's a culvert crossing somewhere in here. Oh, okay. So this is there's a roadway. You can't really see the roadway here. And somebody's put a culvert crossing under this roadway. Culvert is just, just like a pipe under the road. And so to model that culvert crossing, and I guess all the water, the culvert crossing, maybe it's right here, but the water from this creek hits this roadway and then flows along the roadway, a roadway embankment until it goes through the culvert. And so to model that, what you have to do is you can create a stream arc that's a roadside ditch arc in WMS. And then any flow directions that hit that arc are going to go along that stream arc to the outlet of this subbasin. So WMS does this internally. So then when I delineate the watershed for that area, I have this whole, instead of having this small 1.16 square mile watershed, I have a larger watershed that includes this larger watershed. So it's 8 square miles. And so you can do that. This is useful for modeling roadway embankments, even if you're in a rural area, or we use it a lot in urban areas. Okay, so quiz question. Features such as roads, canals, ditches, and embankments may be represented by A, selecting a node or vertex and converting it to a stream. B, digitizing a stream arc from upstream to downstream. C, digitizing a stream arc from downstream to upstream, or D, none of the above. I guess I haven't really covered, there's one thing I didn't tell you, but I'll tell you this, it's either B or C. It's not A. So the correct answer is C. You're gonna digitize a stream arc. So whenever you can create these, so one of the steps in watershed delineation is you create those streams. You can select that menu command that creates the streams. But whenever you create a stream manually, you can actually draw an arc or draw a polyline in WMS that just manually draw in a stream wherever you want to draw it. And any water that hits that stream is going to go to the outlet of your water, whatever that stream is connected to. But when you digitize a stream, when you point and click and create a stream in WMS, you want to create that stream from downstream to upstream. If you create it from upstream to downstream, it's going to be backwards and WMS won't know. It'll have the wrong flow direction. So the correct answer is C. Demonstration.
Still demonstration.
I already showed you a demonstration.